So this section here, it's either good teaching or bad teaching. We will see. I'm going to go through and do the problems two different ways. I'm a little torn because the first way, so maybe I'll predominantly use this blue color. The first way goes back to kind of what we've been doing in the last chapter where we're doing like a lot of stuff with ratios. The second way, and you'll notice I have the examples kind of split into two sides. The second way is a newer way. It's faster. It's less work. And it's the way you'll probably learn it when you hit like Algebra 2 class. So my thought is, push comes to shove, do it this way if you need to, but I'd really encourage you to try to learn it this new way. I think you'll like it that way better. But here's the push comes to shove way. If we were to take and set up a proportion, so set up a proportion. Our last chapter we did a ton of these where it's essentially saying one fraction equals another fraction. And as we go through and do these, how you do it is this, that you could say the upper left is going to be the part divided by the whole equals the percent over 100. And if you think back to the last chapter, we kind of talked about how you have to have the same units in both tops and the same units in both bottoms and so on. Would you agree 100% is the whole amount? So then if you're trying to find, say, 80% of that, the 80% would be up here, but that's also the part of that whole. So it's kind of like what we were doing in the last chapter. And typically when we solve these, we're missing one of these things here, and you cross multiply and divide, yes?
Yep.
The nice part with the new way is you don't have as much work in that cross multiplying and dividing. But in looking at this, I commented that you're looking for one of these three. You always know this is going to be 100, right? So you're never going to be missing this. So in the problems that you get, some of them you'll be missing the percent. It'll say what percent is blah, blah, blah. Other ones will say 42% is what, and you're trying to find that part. And the other is going to be this whole. What's that whole amount? So there's three different types of questions, three different examples. That's kind of what we're doing. Want to make a comment. When you have this whole, I've noticed, and then in writing problems, I get the same thing. That whole, that number that goes in there is often paired with the word of. So as you go through and do the problems, we have this thing here of 4,321. So that's going to be a number that we have to put in the whole. The word is that we get right there, is often paired with the part. So I'm going to put is blank up by there. Sometimes it'll be the other way around. Sometimes they'll say 52 is blah, 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 blah. In which case 52 would be the number you put in there for the part. Fair enough? So the old school way, if we do this first example, and I'm going to try to model showing my work. So if I do the part divided by the whole equals the percent over 100. And if you do show your work on these with this or that new equation, I think you'll just remember it better when you get to quiz test time. But so we have of 4321. So I'm going to put that right away down in the bottom of my left fraction. So 4321 is the whole, because of that word of. 78%, so we could put the 78 in for the percent thing. Would be that over 100. So then that green is what number? The is usually paired up with the part. So the what number is what we're trying to find. The x goes there. Good? So I'm not going to go through and do cross multiplying and dividing on all of them unless you beg me or just ask. But so when we cross multiply, I'll at least show it once. So we do 100 times x equals 78 times 4,321. Then we could multiply those two together. 78 times 4,321, we get 337,038 equals 100x. So now to get x by itself, we would divide by 100. And when we do that, it works out kind of nice because you just move the decimal point two places. So 3370.38. So the 78% of 4,321 is 3,370.38. Good? And then for our second example, And we'll set it up and then just kind of jump to the answer. But it'd be part divided by the whole again equals percent times 100. So what percent? So we're trying to find the percent. So I'm going to just right away put an X in there for the percent. Some people will leave the percent sign. Is 42. So 42 goes in for the, nice, the numerator up there on top, the part, of 57. 57. So we could cross multiply 57 times X equals 42 times 100. Then we'll have to divide by 57. And we end up getting X equals 73.68%. Maybe you rounded that to 74 or 73.7. But does that make sense for that one? Mm-hmm. All right, let's up to the next page and show my work. So part divided by whole equals percent divided by 100. And sure enough, it's saying of what number? So we're trying to find that whole, thing that's paired with that word of. 37 is, so 37 goes in for numerator up there on top, equals the percent, so 86 over 100. And turn my page in my notes. So if we were to cross multiply and divide, we'd get X equals 43. So if 37 was 86%, that'd be 100% of 43. So this other way is going to be a little bit shorter. I'd recommend you give this one a shot. Try to learn this one. So this new one, this is the equation I like. I'm going to say percent times the whole equals the part. So just like before, we still have the whole in there, we have the part in there, we have the percent. Now the thing that messes up some people in here is this percent has to be as a decimal. Remember yesterday's notes, we changed percents into decimals? And how many places did we move the decimal point? 2. So what we're saying is we're going to be moving the decimal point 2 places before we put it in the equation. And that really is kind of the same thing over here. If you take your percent and divide it by 100, that just moves the decimal point 2 places. So we're kind of manually moving it 2 places instead of having to have the math problem, the setup, do it for us. And you could, if you wanted to, label the same thing, that whole, that's going to be the number that's paired with the word of. The part, that's going to be the number that's paired with the word is. And the blank could either be in front of the is or after the is. But if we go through and set these up, the first one especially is really slick. So percent times the whole equals the part. So 78%, I can't just write 78 here. I have to do a 0.78. I'm too used to writing it, I messed up my example. But 0.78. And then we have of 4321. So 4321 goes in for the whole. Nice job, Nate. So beautiful part here is you just multiply the two together. You don't have to do all this cross-multiplying, dividing stuff we're doing. You just do that times that. We should get the exact same answer. So you should just right away jump to 3,370.38. Good? Mm-hmm. The other ones you will have to do a little bit of division or something like that to solve it. But second example, we have percent times the whole equals the part. And so what percent? This one's a little bit weird at the end. So we're trying to find the percent. So you I could put an X in for the percent. That's our unknown. And then is 42. So 42 is going to go in for the part. Of 57. So 57 fits the whole because it's that of in there. And now to solve for X, we simply
42 divided by 50.
Exactly. Get X by itself by doing the inverse of multiplying by 57. And so now when I do that, I get X equals 0.7368. So do we just find that 42 is 0.7368% of 57? You have to, exactly. Just like before we put a number in here, we had to move the decimal point 2 places. The number that's in there had the decimal point moved 2 places. So we need to, that's your answer, you have to remember to move the decimal point back 2. So we get a 73.68%, just like when we did it the other way. This last one, example 3, we could say percent times the whole equals the part. So 37 is, 37 goes in for the part, so it's paired with the is. 86%, right, 0.86 goes in for the percent. And then the of what number? So sure enough, the of is the whole thing, so our unknown is there. So to get x by itself, we divide both sides by 0.86. That cancels out, leaving x by itself. And if we punch that in our calculators, we'd get 43. Make sense? Seem doable?